I'm Anil Kumar. Welcome to my series on calculus. I hope you have already watched some of my videos on prerequisites of calculus. Here is the one where I've taken 4 very important application questions. Question number 1. Write hypotenuse h of a right triangle with area a unit square as a function of its perimeter p. Now in calculus, many times you have to rewrite the functions in different forms and as composition of one another. So this question helps you to understand those techniques. Question number 2. Show that the rate of change of volume of a sphere at any time t is same as its surface area at that time. So volume of a sphere is 4 by 3 pi r cube, and surface area, let me write surface area is 4 pi r square, right? So rate of change of volume is same as that of surface area at any instance of time. This is what you need to show, right? So the concept of instantaneous rate of change will help you get the solution. Question number 3. Simplify the expression cos tan inverse of x. So that helps you to rework on the trigonometric function and especially give emphasis on the inverse of trigonometric ratios. For AP Calculus and IB Math students, that is a must. Question number 4. Find the horizontal asymptote for y equals to x over square root of x square plus 1. Now here we'll understand few very important concepts and see that sometimes an equation like this can have more than one horizontal asymptote. So here I'd like you to find what happens when x approaches negative infinity and also when x approaches positive infinity, correct? So keeping that in mind, I'd like you to make an attempt to solve these 4 questions and then look into my suggestions. Number 1. Write hypotenuse h of a right triangle with area a unit square as a function of its perimeter p. So let's sketch one right triangle here. Let the hypotenuse be h and the sides be a and b. Now let us write down all the equations which are related. So let's begin with area. So area of this triangle, right triangle, will be half AB, right? So half AB is the area. You could also write A times B as 2A. You can write 2A as A times B. Okay, that becomes one of our formulas of interest. The other one is the perimeter. So when we say perimeter, it is sum of all the 3 sides. Correct? So from here, we can write P minus H as equal to A plus B. Now another formula of our interest is the Pythagorean theorem, which is A square plus B square is equal to H square. Now these 3 formulas will help us write H as a function of area and perimeter. Correct? So you have to work with these 3 formulas, rearrange some way or the other to get the result. Correct? So let's begin with, let me number them. Okay, let's write like this. So let's begin with this one first, right? So if I write P minus H equals to A plus B, so perimeter minus H equals to A plus B, right? If I square both sides, that is P minus H whole square will be equal to A plus B whole square. Expanding, I get P square plus, okay, let me write H square minus 2PH equals to, expanding this, we get A square plus 2AB plus B square, correct? Right, now A square plus B square is H square, correct? So what we see here is we have P square plus H square minus 2PH equals to A square plus B square plus 2AB, right? Now look here. we have a square plus b square is equal to h square. Let's say equation 2, right? So here we could replace this with h. And we also have ab term with us. ab is equals to 2a. So we'll call this as our third formula. So replacing ab with 2a. Correct? So we'll replace this with 2 capital A. So once we do that, we have removed a and b, and so we have related hypotenuse with perimeter and area. You get the idea, right? So what we get here is p square plus h square minus 2ph equals to a square plus b square is h square, right? So h square plus 2 times ab is 2a. Does make sense to you, right? So we get our equation. Now bringing these terms together, rather we could cancel h and h. So we have here p square minus 2ph equals to 4a, correct? So as you can see from here, what we did was, at this stage, we cancelled h square and h square. So we have p square minus 2ph equals to 4a, correct? We need to write what h is. So we'll isolate h and bring all of the terms on the other side, correct? So let's rewrite this. So we'll actually write p square, taking 4a on this side, so minus 4a equals to 2ph. Now we can isolate h. So h we have p square minus 4a over 2p. So we got hypotenuse as a function of perimeter p, and we could write this as p square minus 4a over 2p. Perfect. So that is how we can actually rearrange the given equations, which you use so often, and get a very important formula. Right. So we get hypotenuse in terms of perimeter and area. Now it is a function of perimeter since we are given area. So a is constant. Take a is constant. So the only variable here is perimeter. You understand my point, right? So that is a very interesting formula which we can use in many different ways, relating perimeter with hypotenuse. I hope you find it interesting. So you could work with these formulas and get different relations, relate in different ways, correct? I hope that makes sense. Now let's take up question number 2. Question number 2. Show that the rate of change of surface area of a sphere at any time is same as the surface area. So the rate of change of volume, of a sphere at any time is same as its surface area at that time. Correct? So that is the question for you. Now what is the volume for a sphere? Volume is 4 by 3 pi r cube, right? That is the formula for volume. The surface area is given by 4 pi r square. So let us say we have a ball of ice which is melting, volume is changing, and we want to find rate of change at a particular instance of time, correct? At that time the radius will be changing. So at that time we say the rate of change of volume is same as the surface area at that time. That is the application, correct? So let's see how to find rate of change of volume. So let's find instantaneous rate of change. So to find instantaneous rate of change of volume, what we need to do is we need to compare two positions where the area is very close, the radius is very close by. So the instantaneous rate of change formula which you have been using is the value of the function, that is the volume of the function, at some value a plus h, right, minus the value of the function at a over h, where h is approaching 0, very, very small. That is how you have been finding instantaneous rate of change, correct? So where r is equal to a at a given time. Perfect. So in our case, instantaneous rate of change of volume is equal to, so in this function we could change r with a plus h, right? So we get 4 over 3 pi a plus h whole cube minus 4 over 3 pi a cube divided by h, correct? Now we can expand this and simplify, correct? We see that 4 by 3 pi is common, h is common. So we could write this as 4 by 3 pi, we can take h also common, and here we get a plus h whole cube minus a cube. Right, so remember h is very, very small as compared to 1. Right, so you can expand this and simplify. So what we get here is 4 by 3 pi over h, h. Expanding we get a cube plus 3 a square h plus 3 a h square plus h cube, correct? That is the expansion of a plus h whole cube minus a cube. Now a cube and a cube will cancel. We are left with few terms here and h is common in all of them. So what we get here is 4 by 3 pi over h, and we have 3a square h, let me rewrite, plus 3ah square plus h cube, correct? Now we can take h common, so we get 4 by 3 pi over h, okay, pi over h, and in this we take h common, so we get 3a square plus 3ah plus h square. Now we could cancel h with h, correct? Since h is very small, I could write this expression, which is 4 by 3 pi, within bracket we have 3a square plus 3ah plus h square. Since h is very small, since h approaches 0, 3ah will approach 0 and h square will also approach 0, right? So these two terms will be as good as 0. So what are you left with? You are left with 4 by 3 pi times 3a square. 3 and 3 cancel, and what you get here is 4 pi a square, which is the surface area. Correct? So when the volume is 4 by 3 pi a cube, then the surface area will be 4 pi a square. Do you see that? So that is how we can show that instantaneous rate of change of volume is always equal to the surface area at that instance. Perfect? So that is how you derive the very important relation. Now let's take up question number 3. Question number 3, I have converted that into a multiple choice question for you. Now the question is, simplify the expression cos of tan inverse x. What is it equal to? 4 choices are given to you, right? You can pause the video and answer the question. Now I'll try to solve this in 2 different ways. You can adopt the method which you think is easier for you. Understand both the techniques. So whenever we talk about inverse function, we have tan inverse x. Let it be equal to y. In that case, x will be equal to tan y, correct? So when I say x is equal to tan y, now I could actually from here solve it in 2 different ways. One is we could take a right triangle where we say tan y is x, so this is y, and tan is ratio of opposite over adjacent side, right? So that becomes the scenario. So this is our right triangle which represents tan y equals to x. In this case, what is the hypotenuse? The hypotenuse is 1 square plus x square, square root. Correct? So what we have here is that triangle represents tan y equals 2x, right? Now let's look into our equation. We have cos of tan inverse x. So cos of tan inverse x can now be written as cos of, since tan inverse x is y, cos of y, correct? Now what is cos of y equals to? Cos is adjacent over hypotenuse, right? So cos is equals to adjacent over hypotenuse. Perfect. So therefore, from here you can write it is 1 over square root of 1 plus x squared. Is that clear? So we have option A as the right option. You get the idea. So that is one way of doing it. The alternate method here is that we know the formula 1 plus tan square theta equals to secant square theta. Correct? So we can use this formula and find what secant theta is. Correct? So in this case, using that formula, we have tan y. So we know tan square y plus 1 should be equal to secant square y, correct? Now tan square y is x, so x square plus 1 is secant square y. So secant square y is square root of this, right? So I can write secant y is equal to square root of x square plus 1, correct? Now secant is reciprocal of cosine, so we get cos y equals to 1 over square root of x square plus 1. So we again get option A. Now if it is given as a multiple choice question, you can always take option A and that's it. But if it is not given as a multiple choice question, caution. Caution is that whenever we work with inverse function, we have to restrict domain. Correct? So for a tan function, what is the function like? So it's kind of like this. The graph of a tan function repeats like this, correct? So what we normally do is we always restrict this domain for the inverse of a tan function within the interval minus pi by 2 to pi by 2, correct? So when we solve this question, correct, in that case, we have to say that the angle is within this interval. Do you get the idea, right? So we have to say that the value of y, this value of y is between pi by 2 and minus pi by 2. Is that clear? So this is a very important restriction which should be placed if it is not a multiple choice question. Do you agree with me? That is how we should be solving. So at this stage, I have to write this comment and then continue, and you can adopt any one of these methods. Perfect. So that is how you could solve it. Now let's take the last question. Question number 4. Find the horizontal asymptote for y equals to x over square root of x squared plus 1. So when we say horizontal asymptote, what are we trying to say? It is actually behavior of the curve as x approaches large value. So that means x approaches either negative infinity or x approaches positive infinity. Both sides, correct? That is what it means. So what I'm trying to say here is when we are trying to find the horizontal asymptotes, we are trying to find what happens when x approaches minus infinity and what happens when x approaches positive infinity. If it approaches a value, then the horizontal asymptote exists, right? So that is what we figure out, correct? So let's try to find what happens to this function when x approaches positive or negative infinity, correct? So that's the key to our solution. So let's begin with our solution, keeping this in mind. Okay. So we have the function y equals to x over square root of x squared plus 1. We could write this as x over, within square root, I can take x squared common. So I get 1 plus 1 over x squared, correct? Right? Now, this could be written as x over, taking out x squared from the square root, what will I get? Will I get x 1 plus 1 over x squared? This is your question. Is this correct? Is this correct? So the answer is this is not correct. It should be absolute value of x. This is key. So this is note. Square root of x squared is not equal to x. It is equal to positive value always and is equal to square root, absolute value of x as shown here. You get the idea. This is one thing which you should know very clearly. Now the thing is, we have to look into two conditions. What happens when x approaches negative infinity, and what happens when x approaches positive infinity? So we'll solve this equation accordingly. So we have y equals to x over absolute value of x square root of 1 plus 1 over x squared. Here also we have y equals to x over absolute value of x times 1 plus 1 over x squared. Now in both the cases, if x is very large, positive or negative, what we see here is that 1 over x squared will approach 0, correct? So 1 over x squared will approach 0. So what we get here basically is that y is equal to x over absolute value of x, correct? Because 1 plus 0. So we get y equals to x over absolute value of x. Now, when x is approaching positive infinity, what is the value of absolute value of x? And what is the value of absolute value of x when x approaches negative infinity? Can you write that down for me? Well, this is how we define absolute function. It is equal to x when x is greater than or equal to 0, and it's minus of x when x is less than 0. So in this case, when you're approaching negative infinity, this will be equals to minus of x. And when it is approaching positive infinity, it will be plus x. Now clearly you can see in this case y is equal to 1 with a negative sign, and here y is just 1. Since we get a value, it is approaching a constant value, there is a horizontal asymptote, right? So we have a horizontal asymptote which is y equals to minus 1, and in this case y equals to plus 1 is the horizontal asymptote. You get the idea. So we get two horizontal asymptotes. Here the asymptote is at x, y equals to 1, and here y equals to minus 1. So for this particular case, we get two answers. So the horizontal asymptotes are y equals to plus minus 1, as you can see from the work which we have done. So I hope this is absolutely clear. Now you have worked a lot with such functions, but if you make a mistake of not understanding what is square root of x squared, then in calculus you're going to lose many marks. So be careful about it. And I hope this example really helps you to understand the concept. So with these 4 examples, I think you should do fairly well in calculus and shouldn't be very difficult. Feel free to write your comments, share your views, and if you have questions, please post them. Also, you can send pictures of the questions to my email address given below. Thanks a lot and all the best.